Okay, it's Wednesday. Happy Wednesday, everybody. Hope everyone is doing well. Fingers crossed we have a good stream tonight. Hopefully what I have planned will actually come off tonight as opposed to what happened last time. But, you know, we roll with the punches. We keep going. Hello and welcome. So tonight we are continuing the project of building the LumenPnP. Last stream, we did some work on assembling the x-axes, and we found out very quickly that we had made a miscalculation in requiring M3 hardware for the linear bearings that are used in the system. So in my little box of goodies here, I have managed to source some M3 machine screws and also some M3 T-nuts that we can now go ahead and start installing the bearing system in the frame. So before we get to do that though, we're going to start work on the x-axis, and that also involves working on the the Z carriage. So we've got to do some preparation work. If we don't want to disassemble the Z carriage, we need to build it out with all of its hardware. So when we are ready to install the linear bearings for the vacuum NEMA motors. So we have two NEMA motors that are on the Z-axis, and they are connected to the system, and they rotate the components that we're placing to the correct orientation, and they have a vacuum line so they can actually grab components. So yeah, we need to make sure that we've got all of this installed properly. So let me grab, I've also got my other camera set up a bit better than it was before. I've now got this camera set up with pretty much no latency. So we'll be glad to know that we can get into this build. And from a technical perspective, we should theoretically be in a good position with not to have any problems. So this is the Z carriage, and on here we have to mount a set of linear bearings, and on these linear bearings there will be two miniature or like sub NEMA 17, I think in a NEMA 12 motors with a hollow shaft, and that is what carries the vacuum to the nozzle end. So there's two of those there. We've got a switch, limit switch that goes here. The NEMA 17 that drives the Z-axis goes here. And we've got some bearings and pulleys that need to go in here. So that's what we're going to do. We're going to install all of these nuts and stuff. Hey, Dimitri, welcome in. How you doing? What should I know by now not to say? What have I said? No technical issues or limited technical issues, right? There are no guarantees. Right, so I'm going to grab a M5 by 40 bolt, and I'm going to grab my M5 nuts. And one of the things that we've got to do is we've got to press fit all of the nuts into the back of this unit. We'll start with this one first, I think. Should covers a multitude of sins, right? Shoulda, woulda, coulda. And 2020 hindsight is a wonderful thing. So yeah, as you say, let's not tempt fate. So what we're going to do is we're going to get these bits of hardware installed, and we can get moving, right? So what do I need? What do I need? First and foremost, I need to check the clearance on these bolts. Will they go all the way through? They will indeed. So that is good. What about here? Okay, so these holes for the belt tensioner, they need to be finagled, shall we say. We seem to be suffering with a little bit of elephant's foot on this section here. So let's go ahead and just get rid of that. So elephant's foot, if you were on stream last time, you'll have heard me talking about elephant's foot. What elephant's foot is an artifact of 3D printing, specifically around layers 1 to about 3 or so. And essentially what this is the nozzle is really close to the bed. And as it injects the plastic onto the bed, it spreads out. And as it builds the model up, when you take the model off and look at it in profile, you get this line that comes down, and then there's like a bulge at the bottom, very much like an elephant's foot. Now, there is some compensation that you can apply in some slicing softwares, but I've not applied it here. So I'm going to have to take a file and just remove that material. Joko! Oh, it is a challenging build. How are you doing, buddy? Hope you're doing really well. We are currently building out the linear motion system for the pick and place machine. I'm not sure if you're aware of the reason behind the build. So I have a side commission that I need to manufacture a number of boards, circuit boards. Now, we've made some prototypes. Those prototypes took me about 3 to 4 hours to assemble by hand using soldering iron, and we're talking, you know, SOT 23 and 0805 scale components, which are tiny, right? They're quite small. So that's great for prototyping, but in terms of a batch run, which is what we've got to do next, we need something which is a little bit quicker. So we're going with the LumenPnP from Opulo. It is an open source project created by Stephen Hawes, and he has made this machine completely open source. We're using FreeCAD. In fact, that just reminds me, I've not launched FreeCAD yet. So let me launch FreeCAD. We can bring the model up. So yeah, we're using FreeCAD for the 3D elements that need to be 3D printed, and we are assembling this guerrilla style. There's no instructions. I'm glad to see you doing well. I'm doing good too. Thanks for asking. Soldering iron, hot air, screaming, right? Tons of frustration. All the fun of the fair. Well, the suggestion of loss of sanity suggests there was sanity available to lose, right? So, I mean, at least I got that going for me. Some of the projects I take on are, you know, you just have to question whether or not I have sanity built in. So, so yes, the likelihoods that this machine will not be ready for the batch run, certainly the first run. So the theory that I'm working on is that this will be available for either the tail end of the run, or it will be available for batch 2, if there is indeed a batch 2. Listen, there's a quote from one of my favorite films, and it's from The Matrix, and it's know thyself, right? If I know my weaknesses, better than anyone else, then I'm in a good place. Right, so I have pressed the nut into the 3D print, so it's now flush, but it's got to be drawn down into its location. So using this bolt, I'm now going to just tighten it down just to draw. I'll do this up close to the camera. I'm going to draw that into its place. Now, I could use a soldering iron and try and melt it into place. But because of how deep the hole is, I'm probably likely to damage the walls of the 3D print. This is like a dark filament and trying to get contrast so you can show you. So all I'm doing is drawing that down until I feel resistance, and then I back the bolt off and we can go again. We've got 4 of these nuts to install, and that holds this faceplate on like so. All right, so let's get those installed, and then we can move on to the next step. I'm really looking forward to getting this all put together. I have parts on order. So I have the standard the standard Lumen. I keep calling it Opulo. That's the company name. The product is the LumenPnP. So the standard Lumen comes with 2 staging plates, and they are 600 by 120 circuit boards. So what I'm choosing to do, I'm going a slightly different route. I am using 3mm aluminium sheet, cut 600 by 120. And I'm going to export the stage from FreeCAD. And I'm going to do a CNC setup. And I'm going to drop those staging plates onto my CNC machine and cut out all the mounting points. Here we go. We're drawing in nut number 2. So we're going to make that from scratch, and then we're going to paint them up. I'm going with a bit of a black and yellow theme. So I'm thinking about painting the stages yellow, signal yellow. So it would be nice to see if that will work. So I'm waiting for those stages to come in. Now, when the stages have been machined, it's going to look almost like a finished article. But that couldn't be further from the truth. The next things that we've got to do, apart from throwing things around my bench, we need to get the circuit board made for the motherboard. We need the circuit board made for the camera lights. And we need all of the electronics, so the vacuum pumps. There's a bunch of things that we need to get together. The NEMA, the miniature NEMA motors. I think either NEMA 8 or NEMA 12 motors we got to get. So there's still ways to go before we can call this project done. Okay. So we're in good shape there. So those are in. Now I have a sneaking suspicion I may need to install some nuts into position with a soldering iron. I'm just noticing that there's these 2 slots here for square, flat nuts, but I don't have any. I do have, however, some M3, just regular M3 nuts. So I think I'm going to see if I can install these with a soldering iron, but we'll come to that in a second. Right, so now I've got to install these 4 nuts here. Same methodology as we did for these ones. These nuts are here for the not the belt tensioners, but the belt clamps. So I've got some 3D printed belt clamps that take the GT2 belt and clamp them onto the backside of this module, and that'll hold the belt in place, and then we can tension it with the adjuster at the end of the Y at the end of the x-axis. So I'm using a smaller screw or bolt because I don't have to go so far through the material. But the method is the same, right? We put the nut in place and then we draw it into place using the Allen wrench. So how is everybody doing this evening? I hope everybody is good. I'm pretty excited for tomorrow. I'm a big fan of space and rockets and all of that sort of good stuff. And if somebody's watching this on a replay in a couple of weeks or months' time, this is going to seem a little bit out of date. But we have the launch of Starship from SpaceX tomorrow. It's launch number 3. I am super excited to see the results of that. It's going to be a pretty impressive flight if flights 1 and 2 are anything to go by. And yeah, success or no success, it's going to be impressive. I'm actually going to use a longer bolt because I'm struggling to get my fingers down into the pocket to get the nut to draw into the pocket for it. So just do that up by finger tight, and then we'll drag it in with the Allen wrench. All right. So if anybody's watching and has any questions about what the project is, what we're doing, feel free to ask away. So I've got one of the big things about me live streaming and content creation in general is I like to share and I like to show people what is possible. Sometimes I show people how not to do things because I make mistakes, and that's okay. I'm not shy in making mistakes. It's part of learning. You can't make an omelette without cracking eggs. All right. So yes, lots of fun of the fair. And this is, I don't know if you're noticing, I'm dropping things quite a lot. And I guess as I'm getting older, one of the things I am starting to notice is, apart from my eyes not being as good as they once were, I am noticing that my dexterity is not what it once was. The joys of getting older. But we persist. I should get a drop counter that you guys can increment in chat and keep a tally of how many times I dropped something. There you go again. That would be kind of funny. All right. That was an intentional drop, honest. All right, let's fire up this CAD model because we're going to need to check. We're going to need to check we haven't missed anything. There's quite a lot going on in this tool head that we're putting together. And we need to make sure that once we've assembled it, we haven't missed something that when we try to assemble it would be an absolute nightmare to try and install. So your version should be you can't make a sense circuit without ground. Oof. That cut deep. That cut deep. Well, you know. Maybe I should laser engrave that statement onto a board and hang it on my wall behind me. Okay, let me just check something here. Cool. Okay, we got one more nut to install that is obvious, and then we're going to switch over to the CAD model, and we're going to have a look to see if we can find any fasteners that we've missed. And like I say, on the last stream, we found 2 nuts that, had we not installed at that time, we would have had to have stripped the NEMA 17 motor out of the setup, installed the nuts, and then reinstalled them. So it's an absolute nightmare. Because when you consider all of the build instructions that I've seen, these are all to do with a LumenPnP that is part of a kit that you bought from Opulo. And if anyone's interested in checking out Opulo and the LumenPnP, if you're watching on YouTube, if you take a look in the description of this video, there are links to both the GitHub pages and also the Opulo main website. So go and give that project a look. Okay, so we definitely know that we've got 2 nuts that have got to go in here, but what else have we got? So I'm gonna fire up the soldering iron, just get that warming up, and then we're gonna jump over to the PC. We're gonna have a look at this model. Now, I say this every time I'm on live, that I am incredibly impressed with the level of detail that has gone into the documentation for this project. I am not kidding when I say I've seen commercial projects have less documentation than what we see in this. So this GitHub repository not only gives you all the 3D files, but it gives you all the circuit board files and everything you need to make this machine from scratch, which is what we are doing. So let's zoom into the back here. We know we've got those 4 bolts in place, so that's good. And we've got, okay, so this is the camera mount. We got some M3 hardware here, right, for the camera mount. So we got it. That's what those nuts are for. And I just noticed there's a bolt there. Where's that? What's that for? Is that for... Oh, I've just lost my orientation completely. Where am I? My brain has just kind of just been flipped upside down and I'm not quite sure which way's up. Okay. There we go. Right, so we have something going on here. And I am not entirely sure what. Is this another set? Right, so this is what appears to be some hardware to mount the camera. I've got to try and figure this out a second before we progress, because it's quite important that I don't have to strip this tool head down, because that would be problematic. Right, I got to figure that out. What are you? What are you? All right, first and foremost, where are you? I've lost you. I might need to deactivate some of the 3D geometry here to figure out where we are. So we've got this here. I think that's part of the camera module as opposed to... It is. It is. So we've got this section here. It's the camera and light. It's part of the camera mounting. So we don't have to worry about that. This is just, it's just the nut that goes in here. So let me grab some hardware and we will look to install these nuts. Now, the original calls for a flat square nut to be installed, and I don't have a flat square nut. But what I do have is a hex nut, a standard hex nut. So what we're going to do is we're going to use those instead. Now this could go horribly wrong because the idea is that these are pushed into place. They follow a slot. Yeah, right. Well, proverb. You can't make a center circuit without a ground. I'm sure there's a proverb in there, right? Wise man once said, all of that sort of fun. Okay, so that could possibly be jammed down in there. So let's see what I can do. I don't want to jam it down without heating it, because if you press down here, if I press, right, I'm struggling to show you. Let me see if I can zoom in a moment. This is gonna be a bit pixelated because it's gonna be a digital zoom. I am working on an optical zoom, but that's for a project for another day. Right, if I turn this on, there we go. It's slightly zoomed in. We're going to stay on this mode from here on out, I think, because it gives us a little bit of a closer look at what we're doing. So we've got this little standard hex nut, right? And it needs to go down inside this slot. Now, this slot is either what would be considered a friction fit, I guess. But it is really, really tight. So I've got two options. Let me see if I can get a file that I can use. I've got a pointed file here, which is about the right thickness, that I can potentially use just to widen and up these holes and just ease them a little bit. So all we want is to ease this so that they'll go in. Now, these were printed without support, so the upper layer or the bottom, this edge here, may have a little bit of artifacting going on, in the sense that the filament would have been floating in midair. So if I can just get these started, that would be good. Now, one thing I do know for sure is I'm not going to be able to push. Let's think ahead, right? So I'm not going to be able to push the soldering iron down into this because I'll melt the plastic. So what I want to do is heat the nut up sufficiently that I can then use my file to press this down the last mile, right? Get it to where it needs to be at its end point. And then maybe come back in with the file to ease things if I have to. I mean, once it's in there, it's in there. It ain't coming back out. So if I mess this up, this is a reprint. I'm going to have to reprint this. So let's see if I've eased that enough. Okay, that's actually not too bad. Let me get my pliers. If I push that in too far, that I'm going to have to now send it. No, I can. I'm going to try and see if I can file this to a point where I can push in by hand. That would be kind of cool if I can do that. That would kind of like be the best case scenario. But if it does go too far and I can't get the soldering iron on it, then we're in trouble in the sense that I'm going to have to just send it. Just have to send it with the file. But we shall see. So as I mentioned before, we're live streaming on Twitch and YouTube. We're live streaming on both platforms. if you are on Twitch and you are not following, go ahead and hit that follow button. Follows are free. And if you are on YouTube and you're not subscribed to the channel and you like all things 3D printing, laser cutting, CNC, project related, CAD, electronics, programming, if you like all of that sort of cool stuff, go ahead and hit the subscribe button. Give the video a thumbs up while you're at it. It's surprising what good that actually does for a channel. Right, okay, we're going to use the soldering iron. I don't have the time to spend on this. So we're using a soldering iron now just to heat the nut. And then once it's heated up, it should start to sink down into the slot. Let's give it a thick part of the iron. Okay, we're starting to move. Okay, now I'm going to use the file to send this down into the slot to a depth that we can see. It's almost like it wants to go, but then it's like, no, don't. It's giving me vibes of I'm struggling. So let's take it out before we lose the ability to, you know, we don't want to get it jammed in that hole and we can't do anything about it. So I'm going to attempt to widen this hole again. This stuff can be a little bit frustrating. Sorry for the earthquake cam, by the way. Just noticed that. Right, are we going to send that, or are we going to attempt to get that a little bit wider? I think we're going to try and get find the edges a little bit. As I say, this is intended for a square nut, which I do not have. So we're kind of swimming against the tide here. I'm hoping I can get that down in there, and let's send it. Let's send it. Let's see where we go. Nope, that is not, definitely not ready. That is definitely not ready. I'm glad I didn't push that too hard, because otherwise I could be in a world of trouble. So yeah, we're gonna have to work this a little bit. Wasn't expecting to have this problem, but anyway, we live and learn. Okay. I can't tell whether this is because this nut is going down because it is rotating in the slot and it's not going down square where it needs to, or whether or not there is a narrowing of the slot and it's just jamming up. How fine is this tip? Can we get it down there? I think we're going to have to try, because otherwise we're going to spend all night attempting to solve this problem with little success. So let me get a bit of slack on my cable, and we're going to put some downward pressure. I'm hoping to see this go down into its slot. It's going. Okay, we're beyond the point of no return right now. We are catching. Okay, it's warm, so can I push it down with the file? That's the question. Please say yes. You need to move quickly. Okay, we're down in there. And I think it is cooling. Yeah, it is cooling. So what I think I'm going to do, I'm going to have a look to see if I've got a blade, a bladed soldering iron tip. Turn this soldering iron off. I'm going to use a different iron, I think. That might yield us a better chance of success. I'm going to use a different iron. I'm going to put a bladed tip on it, and then we're going to push that down into the hole. So let me see if I can just rig this up on the fly. So first things we need to do is find the tip that we want to use before we start getting this warmed up, because trying to change a soldering iron tip when the iron is running at, you know, I don't know, 400 degrees C, is probably not a good idea. I think my hands may have a little bit of complaining to do at that point. Right, let's go to my soldering bin. We should have a series of tips here that I can use. What do we got? Oh, we've got a blade. We have a blade. Here we go. So what I'm going to do is use this soldering iron tip. We can plug this in. We can use this instead. And we can increase the surface area that we can apply heat to the nut, and hopefully, because of the size of the tip, we're not going to do much in the way of damage to the 3D print. Remember, if I mess this up, then we're looking at a reprint of that component. Now I'm hoping the installation of this axis is going to speed up once we have these last two nuts in place, and we can start assembling the X-axis. Right, where's the plug? That just went for a walk. Okay, we plugged it in. Let's put that by there so that won't fall off again. Oh, that's the theory. All right, power this iron on, and yeah, about 450 degrees C, which yeah, it's a little bit warm. It is a little bit warm. And then once I see it down in the hole, I'm going to use an M3 bolt just to finagle it just into its final resting place. And that should hopefully be that. So this is a little bit of a saga, to be honest, but being honest with you, that's part of the parcel of doing things from scratch, as opposed to buying the item. I guess when you buy if you're buying an open source project, what you're actually buying is the time that you are not installing this stuff yourself, right? Here it goes. There it goes. Okay, there's probably going to be the sweet smell of PETG plastic burning in my workshop. If you hear a smoke alarm going off, I'm hoping my noise cancelling will cut that out. But yeah, there is a possibility that my smoke alarm may go off. All right, so we've got that nut in place, and the screw is there, right? So that we know that is a successful method. We do need to clean this up. There is a little bit of melty going on around the hole, which, you know, we're going to have to live with at this point. Now that nut just went straight down. So can I just push this in without having to melt anything? Yes. Well, there's a spot of luck. Please tell me I was filing the correct slot. That would just be my luck. Right, let's power down the soldering iron. We don't need that. All right, so here we go. Here we go. Let's get moving on the assembly. Let's put this iron somewhere where it can't bother anybody as it cools down. And we can now get rid of this power cord, which I've just thrown across my bench. Alrighty, let's go. Let's go. Right. So, first things first, we need... I picked up that soldering iron tip then and I had this horrible thought, it's hot. It's funny what your brain does to you, right? So let us get... In fact, we're going to actually zoom out here because we do not have full visibility of what's going on. I'm going to leave the hardware off this faceplate. I could take the time on the stream now to go and install the hardware on the back of this faceplate, but we've done that enough tonight. And this is easily accessible. I can take this off the back plate and easily install that in the face. So I'm not going to do that now. I'm happy to postpone that piece of work. So let's jump back. Let's jump back to this view. Okay. And now let's bring in the x-axis. And we're going to start looking at what we need to work on. So here is the x-axis. We've got a NEMA 17 motor on the one side, and on the other side we've got a pulley in an arrangement for adjustability. So we have to install the linear bearing across here using M3 hardware, and we have to then thread the belt, and we have to install a pulley. So there's a few bits that we need to do. The first thing we're going to do is we're going to grab the bearing and we are going to prepare the bearing for installation. And this is a bearing that came 550 millimeters long, and I had to cut 25 millimeters off the one end. So if you notice there's some discoloration on this one side, that is because of the cut operation that I needed to do in order to make it fit on the axes. I couldn't find a supplier that would send, that would supply me with the bearing at exactly the correct length, which I think is 525 for the x-axis off the top of my head. I think they're 550 on the other axes. So what we're doing, this is poor man's knolling. In other words, we're just making a mess. We're just laying out some components that we need in order to install this on the axes. Hey, you doing? How you doing, buddy? We're live streaming on Twitch and YouTube, and we're putting together the LumenPnP motion system. We're installing the bearings right now. I had some issues with hardware, shall we say, but that has now been corrected. I appreciate you're here, and thank you so much for hanging out, buddy. How are you doing? Hope all is well. So I'm just going to remove this rubber bung, and I'm just going to place it at this end. I'm going to leave that open, and I'm going to slide this up, and then I am going to press out the rubber bung here, and then I'm going to place it let's say by there. I'm going to give it a bit of wiggle room so I can get to some of these holes. I do not want to remove this carriage, right? There are bearings that sit inside this carriage. You can just about see them. That if you remove this carriage from this bearing shaft, then the bearings just go everywhere, right? So it makes a hell of a mess. So we're not going to do that. We're going to avoid that at all costs. And all I'm going to do is I'm going to drop an M3 hex nut into here, and I'm going to twist on a T-nut a couple of turns. In fact, it'd be good if I had an Allen wrench that fits. It'd be good if I had an Allen wrench that fits this, which that does. And what I'm going to do is I'm going to put every other hole, I'm going to put in a T-nut and a screw. How's things with you? You do it? You all good? So we're multi-streaming on Twitch and YouTube, and yeah, we getting my watch hours up on YouTube because I am aiming to achieve monetization. I have the subscribers now. But I don't have the watch hours. So I thought I live stream on Twitch. It would be really good if I live stream on YouTube. And Twitch has recently changed their terms of service to permit multi-streaming, which is an absolute ace move in my view. Yeah, I'm gunning for that magic number for the watch hours. Is this mess in the shed you do it? Is this the new shed that you've built, or is this an existing shed? The struggle is real when you build something, you know, new, and all of a sudden you get what's called scope creep. It starts getting used for things you never initially intended it for. I'm going to put that screw to one side. I don't know if the threads are messed up, but it didn't want to catch the T-nut. It could be the T-nut. If this one does it, I'll swap the T-nut out. But if there are any issues like that, I have a tap and die set that I can run an M3 tap in the nut and an M3 die on the screw. So I'm not overly worried if there's a problem. So yeah, I hate scope creep. So now this task can seem a little bit laborious, and to some extent it is. This is why you would buy a LumenPnP, right? You would buy it from Opulo because you don't have to concern yourself with sourcing components or the tedious work of installing M3 hardware to a linear rail. So if you're interested in the LumenPnP, and I'm not sponsored, by the way. I wish I were. I'm not sponsored by Opulo, but I have to say I am incredibly impressed with the project. Not only in the capabilities of the machine, but the documentation that that this open source project has. It's amazing. And when I like to build stuff, but when I get to a position that I can financially say thank you to Opulo, I definitely will be investing in some of their products. So hopefully there's somebody, you know, watching this video during the live or in the replay that hops onto their website and supports them, because it's an amazing project. And as I say, I am not affiliated with them. Wish I was. I could possibly have a free Lumen. Who'd have thought that? No. Thanks, you do it. Appreciate it, man. Damn watch hours, right? Every minute counts. There was a period of time that I was watching the watch hours that I'd accrued dwindle, and at least the needle is moving in the right direction now. It's not moving as quickly as I would like, but it's moving in the right direction. So that is the main thing, and hopefully I can build a little bit of momentum. I'm going to be doing some more projects, and some of these lives are going to be turned into some YouTube videos, actually curated content, which I hope will drive, oh my word, dexterity and words, brain, male brain kicking in here, right? Can't multitask. But yeah, it's a journey in which I'm enjoying. It's good fun. Hard. Anyone tells you that doing YouTube is easy and not a real job, dang, it's hard. All right, we're looking good here, right? We're almost at the point where I can start thinking about assembling this all together. Yeah, slow growth is real great, right? Do I really want to rock it to the highs? I mean, the impatient side of me that wants that wants certain things says yes, gimme. But the logical side of me says no. Slow growth is long tail, right? It's long tail growth. People are sticking around because they like the content, and they hopefully connect with me. It's never guaranteed. One man's cup of tea is another man's poison. All right. And I know, as I said before, know thyself. Know thyself. Know your character flaws. And actually, my character flaw turns out to be a blessing when you want to be a YouTuber. I like to talk, like a lot. I can hear people's eyes rolling into the backs of their heads when I'm in my day job and I give answers. I'm sadly the type of character that gives very long, verbose answers. When a simple yes, no, could have done the job. Right, so I'm trying to orientate the nuts so that they will drop into the V channel. We're almost there. That's looking pretty good. Now, one thing I am noticing, these don't seem to have fared very well in shipping. Hey, Freaky, welcome in to stream. How you doing, buddy? Hope you're well. So one thing that I've noticed is that these bearings, while they did appear to be well wrapped, they have not fared well in shipping. So these are actually bowed, which isn't great. This isn't a sort of full-blown CNC machine, so there's a reasonable chance we can get away with this and actually pull this tight. Right, okay, so I've got one screw attached there, and I'm going to slowly creep up the... I don't know if you guys can make out the flex. Let me turn it on its side. You can see that the bearing's lifted. So be mindful. You get what you pay for, right? These weren't the most expensive bearings on the planet. I am somewhat constrained on my budget. So I haven't been able to buy like Lima bearings or you know, something which is more expensive but ultimately better quality. But it is what it is. We got to make good of what we got. So I'm now slowly working my way up the bearing and hopefully pull it straight along the 2020 extrusion. I have not tried that, Freaky. Is that like a challenge? That sounds terrible. 2 tea bags in a bottle of Sprite. I see these videos on social media that says, oh, combine wine with milk. You'll be surprised. And I'm thinking, really? That just sounds like a waste of wine and milk. It was one of those TikTok things, but you love it. So you actually tried it and found it was good. Some people say red wine and milk is like an alcoholic milkshake. It tastes great, apparently. I mean, I'm reluctant to try that. I'll be honest. Okay. We're getting close now. Now I've just tightened these finger tight, and then I'm going to come back through and just tighten them up again. In fact, I'm going to have a look to see if my driver, I've got an Allen bolt driver. I wonder if that is the same head on there. I'm hoping it is, because then I can kind of give it a bit of torque. It's looking like it might be. Have we got winner chicken dinner? Whoa, we do. Nice. That works for me. Right, so we're just coming back through and just making sure that these are, in fact, I'm not going to use that there because I'm feeling the length of the shaft twisting. So I'm going to come in and I'm going to use the right angle of the Allen wrench to just give these a little tweak. Just tighten them up just a little bit. We tried regular black tea and Earl Grey. Both work great. And now I hate Earl Grey. I hate Earl Grey. I'm not the biggest fan of tea. But Earl Grey, the guy from Sorted Food on YouTube gave it a try and liked it, so I had to try it myself. All right, okay. Well, listen, everybody has their own preferences. Everyone has their own taste buds. Everybody likes different things, and that is good with me. Because if we all like the same things, it would be a pretty boring place. It's sometimes nice to have a contrast and compare. Right, can anybody spot the obvious mistake? There is a mistake in this video image. And I am an absolute doofus for not spotting this sooner. This bearing shouldn't be here. It should be there. In the words of Homer Simpson, don't. So I'm going to cheat. I am not going to take this off because I think trying to get the T-nuts to align again to extract this. Yeah, I know, right, Vex? Trying to extract this is going to be a problem. So what we're going to do is we're going to slacken off the T-nuts for the ends, and we're going to rotate the ends to correct my shambolic mistake. So I can just pop that off, rotate, and then that should hopefully just slide straight back on, and I can just tighten it back up. Now that is way easier than attempting to undo all of those, get the T-nuts to line up so that you can extract it and then try and get it out that way. So this is an easy fix. And a good example of problem solving. Because, I mean, let's be honest, everybody makes mistakes. I know I make more than my fair share. But, you know, there we go. And now I just tighten this back up and we're good to go. It never happened. What are you on about? No, nothing to see here. So these bungs can now be removed, safe in the knowledge that this cannot reach the end. In fact, I'm going to remove this one. And it can slide the full length. I'm not going to allow it. I'm not going to allow it quite yet to go to the very extremes. I think we're okay, but I don't want to risk losing any ball bearings because there is a slight gap at the end of the rail. I might be being oversensitive at this point, but I don't care. I just spent time making myself look like a complete doofus. So, right, we're now going to install the M3 hardware so that this fits. And that is not going to work. So I need other M3. You watch, I'm not going to have the M3 hardware to be able to install this. That would be silly. Especially after this first round of I didn't have M3 hardware. I thought the thickness of that material was the same as the others, but it appears not. I think I am good on this front though. I am stealing M3 hardware from Frank, my 3D printer build. Oh, we're good. We're golden. In fact, we'll see. This may actually be too long. So let's install one, and then we'll see if we are in good shape. Well, that goes there. Let's tighten that. I don't know if this is going to be. Okay, that's not the correct Allen wrench for the job, and neither is that. What about you? Definitely not. No, we have an Allen wrench by here. I'm sure it's you. Right, okay. I'm hoping this doesn't bottom out before it gets... It does bottom out before it gets to where it needs to go. Okay, so this is too long. Ooh. Now we're okay for the Y rails, right? I know we're okay for the Y rails because I've test fitted them. I should have test fitted the Z rail, but I didn't. Right. Okay. Ooh. This could be the promised land. Come on. Come on. Oh, look at that. Look at that. As if it grew there. As if it grew there. Oh. Well, it's a bit of an emotional roller coaster, me doing projects. I gotta be honest. Oh, yeah. That's good. That's good. I likes. Okay, so what we're going to do is we're going to pop these in. And this is the Z-axis carriage going on to the X-axis. And then once this has been installed, we can pretty much take the stops out because we know we're in very good shape at this point, that it's not going to crash into anything. Right. Just slacken off this and this because I want all of these to kind of grab, not cross thread. So the last thing we need is things cross threading. Okay. Okay. We're almost there. Excellent. Okay, just tighten these up. And then we can start looking at installing the same on the y-axis. So we're going to install the rails on the y-axis. So how many in chat are thinking about using or getting hold of a LumenPnP? So let's have a bit of a poll. Very crude one, but in chat, if you type 1 if you are thinking of getting a LumenPnP yourself, or 2 you're just following on for the ride, that is me attempting to build one from scratch. 3 if it's both. Vex just following on. There we go. Look at that. It's good. All right, I'm pleased with that. So now we've got to thread a belt. So let's grab one of Frank's old GT2 belts. And we're going to thread it, and we're going to figure out what we're going to do with the pulleys. The pulley is not currently installed on the NEMA 17 motor. So we know that we're going to come along here. So let's thread that down there until it pops out there. In fact, let's do that going the opposite way as well. Now this, we may have to use a bit of wire and some tape to fish this through the cavern that is the channel here. Now I could take this off, I suppose, but do I want to do that? Thinking, processing. And for those of you who remember the dial-up days, you can imagine that there is a dial-up modem going off in my head right now. Yeah, that really doesn't want to stay straight. There is a bend. There's a bend in this GT2. Ah, Dimitri, I hear you, man. I hear you. I mean, I don't know about anybody else. What drives people to make? What is your underlying driving force? Is it that I mean, I can speak for myself, obviously. I'm not going to speak for somebody else. But for me, it's been I'm coming from a place of scarcity. Not much in the way of funds. That's been a common theme throughout my life, from a very young age to today. Very, very modest background. And that doesn't change the fact that there are things that I've wanted to be able to do. So being in a position not being able to financially pay for certain things, I've had no alternative but to get off my backside and make it. Okay, what I am noticing is that I'm going to struggle to do up the Allen wrench bolts, the Allen bolts. So I'm going to attempt to just tighten one down. I want to see how the belt runs. So apologies if this is off camera. But right, so the belt is through. right? And we have it around the motor. But the question is how does it run? Does it drag? Is it trying to go somewhere we don't want it to go? And if that is the case, then we need to fix that. But that does. Oh no, that's actually pretty good. So I'm gonna keep it there. I'm gonna find the Allen wrench, the little grub screws that we tighten down onto the shaft, and then I can move on. Okay, so this will come through the front. I've got to bring this back a little bit now. See, I come from a very modest sort of background. There've been times in my life where I've, not had things. Probably as a child, that's where it all started, of course, because like where everything starts for everybody as a child. But my maker journey started when I was a child. In that, there were toys and things that I wanted, and I just couldn't get them because my parents worked hard, but very much like today, with the cost of living and things like that, it's tough. So I used to make my own entertainment, make my own toys to some extent. So yeah, it's like I say, it's been a bit of a lifelong journey, and it's only been like in the last 10 years that I come to the realization that I was a maker. I like to build stuff, but it didn't really click in my head that I was a maker. And it wasn't until I discovered people like Jimmy DeResta, Bob Claggett, David Pt2, the 3D printing nerd, Barnacles. These are the early sort of these are the YouTubers that I discovered and kind of come to the realization that, you know what, I'm a maker. I am a maker. Or at least a budding maker, a wannabe maker. Not necessarily there yet, and my journey continues. Now, I know you guys can't see this, so I'm going to bring this to here so you can kind of see me struggling. What I'm trying to do here is thread the belt down the channel of the 2020 extrusion. We're almost there in terms of getting this routed. There we go. Okay, so I'm now going to pull this belt tight. Going to flap this little gate over, and I'm going to bring this all together. Let's do a zoom in. Let's do a zoom in. I think zoomy. Okay, so now we've got to fish this up through here and then get it into the clips. And I'm hoping that after all of this, there is sufficient length on my belt that will allow this to come full circle. If it doesn't, it's no big deal. I do have surplus, which is really interesting. This is kind of interesting. I did do a size check on the y-axis rails, and obviously they're longer, and there seems to be sufficient belt length for the y-axis. The x-axis is shorter, but it seems as though that the belt may be a bit tight in terms of it being able to reach. I'm looking for something I can use as a loop, and I found a small piece of wire. So I've got a loop of wire which I'm now going to press down into the channel here, and I'm going to pull the belt and I'm going to feed it so that it goes through the loop, or at least attempt to. It's got to go down into the channel, so that's got to go down into the channel. It's got to be low enough that it will reach like that. I felt that go through. So now I've got to push the belt along the channel, hoping that okay, how can I okay, that's not long enough. I need to find something a little longer. I have spied something, but if I chop into that, that is a one-way trip. There's no coming back from cutting what I've just observed. Do I do it for the sake of the project? Well, there's an easy answer to that, isn't it? We always do everything for the project. So we are cutting this wire. I'm spotted. Like so. Done. It's a done deal. Tough luck. And now I'm going to make another loop. Yeah, so the Lumen, as I say, is going to be a really neat tool. It's going to be a big time saver. And the idea behind the Lumen is anywhere from, I don't know, 1 board to 3,000 boards. It's going to assist in the manufacturing process. It's going to speed it up. It's certainly going to automate it so that, you know, once I get to trust the machine, that I can set up a board job and just like walk away and let it run, right? And I can do other things. If I know that a board job is going to take 15 minutes, I can set a timer. I can go and work on another task for 15 minutes, knowing that, you know, when I come back, the job is going to be complete. So that's big for me. You know, that I've got a tool that will allow me to like I say, automate this manual process and save a ton of time. So we're going to pop this loop down here, and I'm really concerned now because can we have a vote in chat? What do we think? Do we think that there is enough belt here to run this axis? Yes or no? Give me a shout out in chat if what your thoughts are. Is there enough belt? Without me having to go and get some out of the spool. Okay, let's hook this up here like so. Now I can pass this through there like that. Let's pass a good portion of belt through there. Right? And now I'm going to roll in like this, and I'm going to pull it up. Okay, that is not going to work. So I'm going to need to come back and not have so much of a loop of material. Let's pop that flat down in there. That's... Oh. You think there's enough? I like your vote of confidence, Freaky. I like your vote of confidence. I'm nervous. I'm not so sure that I do have sufficient material, sufficient belt. Only time will tell. Well, this is a lesson, right? Which way do we feed this through? I'd be interested to know how the guys over at Opulo wire these. I'm finding this time consuming, and I'm sure if you're making 10 of these in a row, that you're going to get into some sort of rhythm. You're getting into some sort of rhythm for belt installations and all of the tricky things that you know as a one-off, trying to do as a one-off is you know, there are probably lots of little tips and tricks. Okay, so I'm gonna bring it to here. Oh, gotcha. Yahtzee. Okay, it worked. It worked. Okay, so now I need 2 clamps. So there's these little yellow 3D printed clamps. They got little teeth 3D printed into them, and they go a little bit like that. And what I'm going to do is I'm going to take this back and give as little material as I possibly can. And I need, don't you dare, let's bring you like that. I need the small hex bolts, the M5x10s. No, I like your vote of confidence. Freaky over on Twitch says that he thinks we've got enough material. I like that positivity. It's going to be close. It's going to be incredibly close. We shall have to wait and see if it's too close. Okay, I'm trying to like leave as much material on the table for the return as possible. Okay, let's drop this in. And now we tighten it up on here. All right. So that is now clamped. I'm just going to tighten this up to... I've probably got 1 millimeter, if that, of material poking out of this side of the clip. I don't think the contrast of the camera is doing us any favors. But looking at that, there is not enough material. Look at that. That is a great shame. All right, so how are we going to fix that? Okay, well, I've got this reel of GT2 belt, which we'll use for this axis, and hopefully I haven't misjudged what I need to do. Otherwise, I'm going to be buying GT2 belt now. Oh my god! Come on, Frank, you can pull through, man. That is correct. So the motherboard will, sorry, the PCBs will come, and they will be in a, well, they'll come in 1 or 2 forms. They'll either come as a single board, or they will come as a panel. So once we've got the panel, either way, we'll have a stencil that we'll apply the paste to the circuit boards, and essentially then I'm thinking and trying to think about what I'm trying to say while doing something I'm thinking about, and my brain is kind of buffering. You know that YouTube logo that hopefully hopefully nobody knows that YouTube or sees that YouTube logo anymore, where the video starts to buffer. Yeah, that's what's going on in my brain right now. But yeah, Dimitri, easy fella. Come on now, be nice. I want positive vibes, man. Positive vibes. Right, so I'm gonna tape this flat, and hopefully that's flat enough for this to pass through the channel. And we're going to use the routing of the first bit of belt to give us a path for the second. What I'm going to do is I'm going to draw the belt out of the channel like so, and we're going to push. I've got a funny feeling this is going to get stuck because this tape bulge is pretty big. I'm hoping it's going to go through. Yeah, it's pulling. You son of a gun. I'm going to have to rethread it. I have to rethread it completely. Bugger. Okay, never mind. So yeah, Freaky. So the answer to your question, it will come as a panel or as a single board. And then when it arrives, we'll apply solder paste using a stencil. We'll then load the machine up and we will calibrate it. And that will then know where the tool head is in 3D space, and it will know where the board is in 3D space. And what we then do is run the job. We have to tell it where each of the discrete components are. And once we've done that, we can once we've told it where the discrete components are, we can run the job, and it picks the components up. It looks at those components in the camera, and then it decides whether or not that component needs to be reorientated and rotated. And if it does, it's mounted on a sort of a miniature NEMA motor. And it rotates it to the correct orientation and drops it down onto the board. Now, once that is complete, we then have to do part 2, which is to get all of those components soldered, and that will involve a reflow oven. We'll need to heat the oven up to temperature, and that will then take the solder through a particular temperature profile, and that essentially then solders the components into their respective places. Okay, I'm playing catch up here. I'm getting a little bit worried now about the other axes. I'm wondering where my miscalculation has come, and the only thing that I can possibly think of is that when I tested the y-axis, which is longer, it didn't have the pulley on the NEMA 17 motor. So I'm wondering if that is where I'm coming unstuck, and it's possible that I need to run fresh belt. I'm still calling this Frank's belt because this was all bought for Frank's build, so I'm still saying it qualifies. May not have been used in Frank himself, but I'm saying it's good. I'm saying it's all good. Right. Okay. So we're now stuffing GT2 belt down. Extrusions. So far, so good. We're on the return journey, and the second time round, it's a little bit easier, right? I'm finding that this is going a lot easier than it did. And Dimitri, don't say a word. I said easier. Yes, plug them in. Plug them in. No, I don't have any test points. I mean, the boards have to be programmed. that you know. So the fact that you can program the board is a really good indicator that it's working. So, all right, we're using our little wire loop. We're gonna feed that down into the channel and just see if we can get that to sneak along, which we can. This is so much easier the second time round. It's almost like I knew what I know what I'm doing now. It's almost like, things are actually working out. I've got to figure out which way through this loop this has got to go. I think it's this way, because when I push down, I want to roll over the loop and the GT2 belt, and then when I get to the correct position, I'm hoping I can just pull it up like so. Oh, and it worked. And now we just clamp this into place. Okay, so let's clamp this into place. Again, I'm going to cut my cloth nice and tight, because I don't know if I'm going to need to use this reel of GT2 elsewhere. So I don't want to be wasteful in its usage. So we're going to just get that to a good place, and then we're going to tighten. Okay, and I have just realized that I have not installed the nut in the belt adjuster. We're going to have to fix that. This belt adjuster, which is here, I've not put the nut in there. So we don't want to tighten this up too much just yet, because I need to open this out and insert the nut. So I'm glad I remembered that ahead of time. Now we're looking reasonably good on the GT2 belt reel. So I think if I had to, I could probably run at least another one, possibly two. What am I looking for, Steve? What are you looking for? You're looking for your M3 box of nuts. There they are. Workshop gremlins were playing games with me. They wanted to see if I was paying attention. So let's pass this through here. Awesome. And now let's use a Allen key wrench to pull that nut into place. I see what you did there, Vex. I resemble that remark. Okay. Awesome. So that's in there. That's now inserted. Now, I think what I'm going to have to do is remind myself that this needs to be done before we do the belt on the other axes. Oh, so you want to play that game? You want to play that game. I see. I see. So this nut doesn't want to play ball at the moment. Okay. I'm not sure if this nut is actually pressing into the plastic. It might actually be a loose fit. And if that's the case, we will leave. Yeah, it's a loose fit. So we'll leave this screw in place. But while it's here, I'm going to put its little hat on. I've got a little 3D printed cap on it that I'm using to have pressure, create the pressure that it needs. This little 3D cap I'm going to put on the nut like so, and that then goes in there. I might show you. It goes in there, right? So, and presses against to create the tension that we need. All right, so now I'm going to get my second brace, and I'm going to screw down here. What am I going to do? I tell you what, I am actually going to back off this a little bit more, as much as I can, like so. Pull it tight, and now I can just place this on here. Put my bolt in place and just start the thread. See, this is actually way more involved than I thought it was going to be tonight, but you know, lessons learned. We are educating ourselves. Now, it's possible that I'm going to have to adjust this in the future, especially the GT2 pulley on the motor. Right, okay, let's get a sharp knife. And we're just going to cut this off here with a nice sharp scalpel. All right, and we now have an assembled X axes ready to be installed. That's pretty decent. I'm pretty happy with that. So let's move quickly on without further ado to let's have a look here. So we now got to install the rail here and over here. So let's get one of the bearings, and we're going to have to repeat this process now. Hopefully we can do this at a little bit of quicker pace than previous. So we get our screwdriver, we got our screws, bolts, whatever you want to call them. Let's grab a bunch of T-nuts, get those on the desk. And then we're just going to populate the T-nuts along here. I'm going to pop this bung out and put it one hole up. And I'm going to do the same on the other end when we get there, I think, because I think we might have an odd number, but we'll see. We'll see. Every other one is going to get a screw and a T-nut. So let's see if we can speed run this a little bit, because we are running long on time, and I was hoping to be further on in this process than we currently are. So now we know what we need to do in terms of the belts. One thing I have noticed is that with the official Lumen kit, these the Y-axis legs, they come complete, completely assembled. So does the X-axis, and you just bolt it all together, right? So I'm wondering how much of a struggle it's going to be to get the Y-axis strung with the GT2 belt. Awesome. hoping we can, like I say, speed this process up a little bit. So Vex, you're very complimentary tonight, I see. Thank you so much. So this one is slightly longer by about 25 millimeters from the last one. Yeah, you always are. You're always complimentary. Oh. I suppose this stream is living up to its name, right? It's a challenging build. It is a challenging build. I know you all too well, Vex. Road Rally Race, how you doing? What step did I forget? You're saying Road Rally says I forgot a step. What step? What does baffled mean? You'll figure it out. Right? Well, that's the intention. That is the intention to figure it out. I'm hoping I can. I don't know. You guys on Twitch tonight, you're being really supportive. Come on, catch. Okay, I'm gonna have to use the screwdriver. I've been able to do this up until this point without the screwdriver, but you're gonna make me paranoid, Road Rally Race, I'll be honest. And like Nirvana said, just because you're paranoid doesn't mean to say they're not after you. It's funny because it's true. Listen, I don't need other voices added to the ones that I already have. Okay? Just saying. Just saying. Can I do it like this? I wonder, can I? That'd be a bit of a cheat if I can. Oh, that works. That works. As he finds it like the last one of this run. So what I'm going to do now is I'm going to go straight into doing the other bearing, right? So I'm going to prep both bearings. We do have a gap. So we started in this hole, and at every other one, we've got a gap here at the other end, which I'm happy to leave. I'm going to put that nearest the NEMA 17 motor, right? So there's one bearing complete. We'll put that in the lumen body, and we're going to go straight on into the other bearing, the final bearing, and we're going to do the same. We're just going to poke out one of the stoppers like so, move it up one, and then we're going to just go straight into putting the T-nuts on here. So I'm looking forward to, right, so the next things that are coming up for the Lumen, I've ordered some aluminium plate for the stages. The official LumenPnP calls for like circuit boards. They use circuit boards as the stage. I'm not entirely sure why that is. I don't know if they're used to carry signal or if they just thought it was a quirky idea to use circuit boards as the stage. But I'm using aluminium plate, 3mm thick, and in the center of the aluminium plate there is a support to stop the plate from flexing anyway. So I'm going to use the aluminium plate, and I've had it cut to the correct size, the correct dimensions. So it's 120 millimeters by 600 millimeters, and I've bought 6 of them. I believe the machine has capacity to take 3. So what's going to happen is these are going to come blank, and I will need to machine them on my CNC machine. And what that will allow me to do is have the comfort knowing that if I mess something up, if I snap a machine bit, if I screw up a job, I've got 3 attempts to get this right before it starts eating into the material that I'll use for the remainder of the job, right? So what will probably happen is I'll fail once. The machine, I will continue to machine that one piece that I've screwed up until such time as I get a known good set of G-code commands out of. So I'll use that one piece really to maximize learning, and then I'll flip it and bring in a fresh piece, run a known good G-code job, and then hopefully we'll have covered everything that we need to, and we'll have the potential for 5 staging plates. That would be kind of cool. Should I need to, or have staging plates that do certain things, and I can swap them in and out and all of that sort of good stuff. So yeah, that's the plan. The order has been placed for the staging plates. I need to wait for that to turn up before I can get into that bit. I then need to source components such as the vacuum pumps. I'm going to have this motherboard and the camera illumination circuit boards made, and then it's a case of populating said boards. So I don't know whether I'm going to do like a live stream where I will put together the motherboard from scratch. There we go. That's the second bearing complete. That was much quicker, right? So I've got into a bit of a rhythm. Let us go over to the machine and let's see if we can get these installed. So let's move the machine down a little bit so you get a bit of a better view. And then we're going to install this bearing onto this channel. And I need a little pokey thing that I can use to change the orientation of the T-nut so that it'll drop. Most of them are going in. And like the other side, I've done that wrong, haven't I? I have indeed. I put it on backwards. I said I was going to put the stopper towards the NEMA 17. So let's try again. Try again. What was I going to say? Oh yes, we're going to be very gentle with the tightening of these M3 nuts, because these bearings didn't travel well through the shipping system, and they are slightly bent. So less than ideal. Had I not been on a time frame, I may well have sent these back. But given that while this needs to be a precision machine, I think I can either tune out the bend in the bearing, or you're like a mad scientist, says Smoke Valley Rose. Really? I would just say I'm mad. So Frank is coming together. Frank is being reborn as a pick and place machine. We are Frankensteining this thing together. And we're going to make it work come hell or high water. And I've got a lot of experience from putting Frank together. Frank was my first 3D printer. It was a Delta printer. Why I thought building a Delta printer as my first 3D printer was a good idea, I'll never know. That, you know, but it taught building Frank and tuning Frank and getting the ghosts out of the machine was, you know, it was a challenge. It was frustrating at times. There were times that I just wanted to throw Frank out the window. And, you know, what it did teach me is persistence. It taught me everything that I need to know about the mechanics and electronics of a small scale CNC machine. And I've been able to go on and use that knowledge to repair much more complicated machines, because I now understand the concepts, and I'm good at diagnostics. I'm a very good diagnostician, technical diagnostician, if you want to call it like that. I'm good at diagnosis, especially for what I do in my day job, working in IT, and that skill serves me incredibly well. Right, let's bring you a little bit closer, because we're now going to have a look at this bearing over here. So we make sure we put the stopper towards the NEMA 17 motor, and we're going to drop this down, try and get the T-nuts to all fall into place. Every one bar one is in place. There we go. There we are. We're in position. We can now start tightening down these. We're almost at the point. We're very close to being able to put the x-axis on the the x-axis on the y-axis. So I think we're going to shoot for that, and we'll call it quits at that point. We'll try, and we'll see whether or not we can do it. So what's coming up next is we have to install the carriages, the Y carriages, and we then have to belt them up with GT2 belts. And then we can install the Y carriage. That is going to be our epoch moment, where we've done all the hard work in terms of the mechanics of the system. Now, I don't know if anyone noticed this last stream. I have installed this extension on my bench, so now the Lumen will sit in position without me having to have it angled in a strange way. Will Frank ever get the chance of retirement? Who knows? Who knows? I guess that question depends on how well this build goes. Right? If this build goes well, then Frank is going to be retired. If Frank doesn't go well, this build doesn't go well, Frank will be retired, like, permanently in the bottom of a trash can. But we shall have to wait and see. Okay. Excellent. Now this bearing makes a little bit of a noise. It's a little bit rough. So, I mean, this may have to get swapped out in the future with some, you know, with better bearings. Maybe I might just make a second machine, right? And that second machine will have better bearings on it. So, all right, let's install the rail. Let's install the carriage, should I say. And then we can start looking at belting up these axes. How are we looking on time? We're running close. We're going to be close, especially if I need to adjust for a belt that's too short. That's going to be so dang irritating if the belt is too short. But, you know, it is what it is. We're recycling parts from Frank. So maybe we have to use the GT2 belt that we've got available to us on the reel. I would ideally like to see Frank's belt being used, but technically they are, because it was all part of the batch of belt that was bought during the build process of Frank. So I'm calling it Frank's belt. I don't care. Don't care what anyone says. It's my pick and place machine, and I'll call it what I want. It's my ball and I'm going home. Right. Alrighty. So that's one carriage installed. Now we've got to install the second. So let's grab the final 3D printed carriage, which I have placed where? Oh, there. It's hiding. And I have done the obvious thing. An obvious mistake. I have rushed ahead and I have failed to install some hardware in this carriage. So we've got 4 M5 bolts to install. So this is going to have to come off, I'm afraid. More haste, less speed. Measure once, cut twice. All of that sort of good jazz. So let's fix that problem as quickly as I possibly can. I'm going to keep going until I get this installed, right? So I need the nuts, and I need an M5 bolt. More Steve, less pace. Thanks, Vex. I think. Well, at least I spotted it when I did, as opposed to putting it all together, only then to have to strip it all apart. And this is this is just making the point that buying a LumenPnP from Opulo is probably a good idea if you have the funds available to do it. I don't have a problem with the price of the unit, beyond the fact that I am incredibly fund limited, which forces me to be creative. If I want to achieve things, you know, certain things, I have to think outside the box. How am I going to do more with less? And that has always been the ethos. Yeah, I can imagine what you would have said to me, Vex, had I not spotted it, belted up, or got to the point I needed to put the belt onto the back of this carriage with the clamps, and the whole thing was like, had to be taken apart. I don't think you'd let me live that down, would you? You keep me honest. It would have been clip-worthy. Most of my streams are clip-worthy. Okay, so those nuts have now been installed in the first carriage. And it was only because I spotted it on the back of this carriage that I picked up and thought, oh no, I've forgotten the nuts. That's not a sentence you want to say very often now, is it? Okay, we got elephant's foot I got to take care of. Where is my file? Have the workshop gremlins had my file? I think they have. Dum 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 dum. Did I not have it here? Here it is. I got it. Okay, so we've got a little bit of elephant's foot to deal with here. So we're just going to run a file through these holes just to take that away. Maybe I need to start thinking about putting some elephant's foot compensation in my 3D printing slicing software, just so I don't have to do this. But, you know, it's part and parcel. Thunderblaze, welcome in. How you doing? We are live streaming tonight on Twitch and on YouTube. We are working on the LumenPnP pick and place machine, and we are in the process of installing the bearings and the motion system. A pick and place machine, if you're unaware, is a machine that is used in fabrication of circuit boards and is used to pick up small components and place them in their respective locations in an automated way. So we're building this machine because I have a series of projects that I need to put these things, put boards together. And I also have some circuit boards that I designed on live streams on Twitch and YouTube, which I'm hoping I can put on my website and sell. So we are, like I say, we are slowing down here to install to build this machine from scratch, as opposed to yes. If you go to youtube.com/IQWorkshop, you'll see the stream there. There will be links in the video description for Opulo. Opulo is the company that make the print and pick and place machine, and there's a link to their website where you can actually purchase a machine. But equally, there is a link to the GitHub repository, which I am currently working from. So this GitHub repository is where I obtained all of the 3D printing files, where all of the circuit board files are, and also where the firmware. You even get the firmware for this machine, which is incredible. I am greatly impressed by the level of detail that this project has got. It's I can't shout out Opulo enough. It would mean that I would not be able, if they didn't make these plans available, I would not be able to do this project, right? I would not be able to afford a pick and place machine. I would have, well, not at this moment. Maybe sometime in a future version of Steve could afford it, but right now, when I need it, no. So, oh, they have the bill of materials. They have everything. They have everything. Now, my costs, I'm hoping to build Frank. Sorry, I'm naming my Lumen Frank because I'm recycling parts from a 3D printer that I built many, many years ago. Back in 2015, that project started. Now, I'm hoping to build the Lumen for approximately £500, $500. But I'm recycling parts that I already have. So your mileage may vary depending on what tools and materials you have available to you. And to be fair, everything that I've got to so far, it's literally been bootstrapped from nothing. First 3D printer I ever had, I built from scratch, like we're doing here with the Lumen. And from there, I've literally gone from strength to strength. I'm now in a position where I've got a small 3D printing farm. I've got laser cutting capabilities. I have CNC capabilities, all because of that one machine that I built back in 2015 that gave me the confidence and knowledge about how these machines work, enabling me to take in machines that would normally have been thrown in the trash and restore them to, I wouldn't say like tip-top condition, but certainly to a functional condition, where I can now use them in my projects. And I've essentially bootstrapped a mini maker space here in the workshop. So it's been a journey. It's not been easy, but it's been fun to learn all of this stuff. Right? Absolutely. You know, there's not so if you want to buy a LumenPnP from Opulo, they are running at $2,000 for a machine kit. And do you know what? I don't think that's a bad price, right? Given the level of effort that I need to put in to build this machine myself. If you want a machine that let's say within a day, you want to have up and running, then purchasing a kit from Opulo directly is definitely a way to go. You know, if I had the funds, I probably would go that route. But by building this myself, I'm getting additional experience using linear bearings that I've never used before. I'm getting experience of building highly complex motherboards for the control system. I'll be having those manufactured and populating them myself by hand. So there's a load of soldering experience that I'm getting there. You know, there is a ton of stuff that I'm going to be, you know, learning as a result of this. So I'm not going to belt these up. I'm just very conscious of time that I've got available to me now. So what I'm going to do is I'm going to install the axes here. I'm going to drop this in, and we're then going to bolt this into place, and I'll belt these up off stream. I want to at least give you guys something to see when all is said and done. So I just need to figure out from the CAD files. Yeah, exactly, Freaky. Exactly. You know, there's a ton of things that, you know, this stuff is giving me the confidence to do that I would never have thought in a million years that I would have done some of this stuff. But it's been great. Okay, so I need to find out what what bolt I need. So if I select this bolt over here, I need an M5 by 25 screw. So what do we got here? M5 by 40, M5 by 25. I need 4 of these. Can I list the resources which you could refer to? So if you go to Opulo, in fact, let me just post this into chat. Give me 1 second. I've got links here. One moment. Let me find it. Is it here? No. Okay, so this is the GitHub repository. This is where I'm getting all of the files from for 3D printing, the 3D model, everything, right? Thunderblaze, if you head over to YouTube and subscribe to my YouTube channel, you can follow on all of the live streams. I built this literally on live streams. I will be putting this into a consolidated playlist. So let me find, and there's Opulo. So Opulo.io, and there we go. So there's the links to the site for if you want to purchase it, which is Opulo.io, or if you wish to go for like the build process that I'm going through, you can get that at the GitHub repository. And the cool thing about the GitHub repository is that it's got all of the files. It's got the 3D files for 3D printing. It's got the files for that's not the correct Nat. So yeah, it's got the files for 3D printing, and it's even got the firmware. So that's crazy to me, that the fact that this literally all there. Everything is there. So if you've got the know-how, right, I need to find 75 by 25, 75 by 40. I'm missing. There you go. Are these the ones? These the ones? Yes. Cool. Had me worried for a second then. Okay, put one by there, and then one comes with me. Okay, so the 25 goes in the bottom and the 16 goes in the top. There we go. That's better. That's more like it. Right, so I'm not going to tighten these down right now fully. I just want to get the threads caught and mostly done up. And I'm going to repeat the process on the other side. And then once the bolts have actually caught and they're tightening up, then I will tighten them up fully. And that just gives the machine the ability to kind of settle into its correct positioning. Right, so now I've got both threads done. I'm going to tighten these up. Like that. Okay, and then finally, we're getting there, guys. We're getting there. Okay. So let me give you a bit of a rundown. So here is the x-axis just here, and then we've got the y-axis just here. Now this bearing is definitely not happy. I think it had a bad journey in transit. So I think what I might do is find some. I might lubricate this bearing a little bit and see whether or not I can kind of like tune out a bit of that problem. But it is what it is. That's what happens when you buy cheap materials, right? They weren't the most expensive bearings. They probably were some of the cheapest bearings I could find. But for right now, it's going to, as long as this doesn't interfere with the operation, I'll be keeping this for a while. And then maybe swap that one bearing out in the future. So what happened to the custom Stream Deck? What, this one? This one, it's still here. It still controls my stream. So it's in use. So I will be, and this is part of the reason that I need the Lumen, is that there was going to be some work done on that controller. So what I'm working on right now, I'm considering a seed project, in that it's going to help me fund version 3 of my stream controller. I need to execute on this seed fund, and that will then set me up to be able to go ahead and start making version 3. Equally, I'm doing some work with some home automation equipment. So I've done a live stream where I designed a 4-channel low voltage switching system. That will work with Home Assistant, and I'll be doing a video on how I'm putting that board together and how I integrate it for an Amazon voice device, shall we say, so you can control it and turn it on, turn it off, all that sort of good stuff. And as I say, it's going to be a 4-channel device. Now I will be doing, it's going to be an upcoming live stream where I'm going to do a variant, but I'm going to be showcasing a different tool. So if you are watching on YouTube, make sure you hit that subscribe button and turn the notification bell on so that you can catch the upcoming live stream for the circuit design. And we're going to go through using a brand new tool, the schematic, the board layout, and potentially ordering that board live on stream. So we'll see, right? Last you saw it was on the breadboard. Oh man! So yeah, that's the stream controller. It's an e-ink based controller, e-ink based, so that the power consumption is low. And I think I've got something in the region of, if I remember right, 28 hours continuous use out of the device, which is brilliant. Right, it's more than enough, and it was primarily built so that I could decouple myself from my PC, because my workshop is split across 2 locations, up here in the workshop and downstairs in the workshop outside, and it I can go down and work on the CNC or the laser down in the outside workshop and use my controller to switch my scenes. But equally, if I go to a convention like Maker Central, which is happening this May, I can live stream from the event and control my stream from a convention center, which is 2 hours away from my home base, and I can control my PC from there. It's pretty cool. About us, I mean, you're saying you're jealous because I'm showing it off. Are you interested in having one of these? I mean, version 3 is potentially a reality, right? Thunderblaze, yeah. So Maker Central is in the Birmingham NEC. There is a bunch of cool makers that are going to be there. The likes, I think Bobby Duke's going to be there. Colin Furs is going to be there. Jimmy DeResta, just to name a few. Nick Zanetti is no doubt going to be there because Nick Zanetti is the organizer of Maker Central. So, well, about us, listen, I mean, at the end of the day, I've been told I've got a voice, a face for radio and a voice for print. So, I mean, if I can do it, I'm a shining beacon for anybody else. So don't be put off from live streaming. Just get on and do it. DIYs. Right then, guys, I'm going to leave you this evening. There's going to be some fun and games if anybody is interested in all things space. If you're watching this on the live replay, then this is probably going to make no sense to you. But there is an event happening tomorrow, which I believe starts kicking off around about midday UTC. There is going to be a launch of SpaceX's Starship. It's the 3rd flight of Starship and Booster, and it's going to be a hell of a show. So if anyone's interested,
head over to NASA Spaceflight on YouTube, who will be doing live coverage starting 8 hours before the launch is due to take place, or at least the launch window. And give them a subscribe, because they do some awesome coverage of everything SpaceX, whether that is out of Boca Chica, whether that's out of McGregor, whether that's out of the Cape. They cover, you know, pretty much a ton of launches. And they don't just only cover SpaceX, they cover Virgin, they cover United Space Alliance. There's a bunch of launches that they'll cover from the East and the West Coast. So until my next live stream, have fun, be safe, and I will catch you in the next one. Bye for now.